By now you should have read in your textbook what a Punnett square is and generally how to set up a Punnett square. I'm going to do one for you guys, and then I'm going to have you guys try and practice and figure it out yourselves. Okay, so watch how I'm doing this one so that you guys can do the next one. We're going to do a Punnett square using the hair color trait for brown and blonde. You'll notice that up here I have capital B equals brown hair. And if you remember from last week, a capital B, this allele for a capital with a capital letter, what kind of allele does that stand for? A dominant or a recessive? Okay, you should have said dominant. So brown hair is dominant, and the lowercase allele then stands for dominant or recessive. The lowercase letter stands for the recessive trait. So blonde hair is recessive. I know we have talked about incomplete and codominance, where they kind of break the rules of normal genetic inheritance patterns. But we are going to go back to our general rule of complete dominance, meaning that if in the genotype, meaning our allele combination, if the dominant allele is present in the genotype, then the dominant trait will show. Okay? I have used an example from my own family. Both my parents have brown hair. However, I have more blonde hair. And no, I was not adopted. So here is my biological dad's genotype, the allele combination. There's one dominant allele and one recessive allele. But he has brown hair because there is that dominant allele in the genotype. Here is my mom's genotype. We have a dominant and a recessive allele together. She shows brown hair, but she does carry this trait in her DNA because it was passed down to me. Okay? Your parent genotypes, one parent will go on the left side, the other parent will go on the top. Now, this can interchange. I didn't have to put the male parent on the top. I didn't have to put the female parent on the side here. I just chose to do that. So if I were to flip it around where the blue sticky's here and the orange sticky's here, we will still get the same outcome. Okay? So let's try this now. We got to fill in our Punnett square. And I have a note over here. Each box represents a possible offspring genotype. And if you look, we have 4 different sections. So what percentage does each of these represent? 1 box out of 4. That means a fraction 1 over 4. What percent does that equal? It'd be 25%. Each box has a 25% chance for a genotype outcome. Remember, genotype means allele combination, what the DNA is. We do not have phenotypes in our Punnett square. So now we have to fill in our boxes. And I'm going to start by bringing down the male parents' alleles. So here, this big B, this capital letter B for brown hair, needs to be brought down twice to the boxes below it. 1 here, and 1 here. Okay, so each letter that is above a box needs to be brought down to the box below it. Same thing with a lowercase b. I'm going to bring it down to this box, and then bring it down to this box as well. Let's go over here. Now that our alleles are on the left side, we need to bring them over to the boxes that are on their right. So this capital B comes over here, and another one is going to come onto this side. like that. Last, we have these lowercase b's. These alleles will be brought over just like they did up above. So now we have 4 possible outcomes for the offspring's genotype. We have 2 capital B's together. And what does this represent? 2 dominant traits together is hetero or homozygous. It is homozygous. Remember, homo means the same kind. So this is homozygous dominant. One note I'm going to make here is whenever we use genotypes in a capital letter and a lowercase letter scenario, we always want to put the capital letter first. And again, what is this called? Hetero or homozygous? Heterozygous, because there's 1 capital, 1 dominant, 1 recessive allele, and hetero means different kinds. All right, we have kind of a similar combination here. We have a capital and a lowercase, 1 dominant, 1 recessive trait. So this again is going to be heterozygous. And here we have 2 recessive alleles together, 2 lowercase letters, hetero or homozygous. Homozygous, because homo means the same kind, and this would be a homozygous recessive, because it's the same kind of the recessive allele. All right, I'm going to set up a new board really quick. And I'm going to have you guys fill it out. All right. Take this board, pause the video. This parent here is homozygous dominant with 2 dominant alleles, and this parent is homozygous recessive with 2 recessive alleles. Pause the video and complete this Punnett square on your own. When you guys are ready, come on back. I left you guys with this board, this Punnett square with a homozygous dominant parent, 2 dominant alleles, and then a homozygous recessive parent with 2 recessive alleles here. You should have finished it on your own, so I'm kind of going to go through this a little quicker. And I'm going to use my markers this time because I ran out of Post-it notes. So we're going to start at the top again like we have. This dominant allele is going to come down here, and it's going to come down here again to the bottom. This dominant allele comes down and again. So the only allele that this parent can pass on is the dominant allele. So we end up with a dominant allele in each box here. Okay. We go over to our recessive alleles. This recessive allele, this lowercase b, is going to come over here to the first box and to the second box. Same thing down here. The only thing that this parent can pass on is a recessive allele. And that leaves us with the same genotype, the same allele combination, same genotype in each of the 4 boxes. And just another quick reminder, with a dominant allele and a recessive allele, is this homozygous or heterozygous? All of these boxes are heterozygous genotypes. Now let's apply that back to our phenotypes, our physical features, brown or blonde hair. Is there a chance? There's a 100% chance of a heterozygous genotype in the offspring. So does that mean they will have brown hair or blonde hair? Remember, in complete dominance, that dominant trait is always going to take over, even in the heterozygous genotype. So the only phenotype possible here in all 4 boxes, 100% of their offspring will have the Dominant allele, brown hair.